So 4 p.m.
Yes. Yes, it is. I had to remind myself of that. I'm
And you're
like
going to be Pacific tomorrow?
no, it'll still be mountain time.
Okay.
So I don't quite get all the way there. So it's all good. Okay, let me give you some sharing
So
access.
4 p.m.?
Yes, it is. I
Here
had to
come the
remind
echoes.
that. I'm like, yep. Okay,
And
hang
you're
on.
going to be Pacific tomorrow?
No, it'll still be mountain. Like we're talking,
Okay.
but okay. Wait. All right, shut up.
You just told our past self to shut up,
Yeah. Like, shut up.
which
All
means our
right.
past selves will tell our past self. Oh, that's okay. Too much.
It's
Anyway,
too much. It's too much. Well,
time.
yes, it's time to talk space weather. Space Weather Weekly.
Is that our
We're
official title?
I think so. I think
I'll
we're
take
rolling.
it.
Yeah. So we're gonna it's a day earlier. Well, I like to do weekends so that way we can do Saturday or Sunday.
Yeah,
But we
the
got
freedom's nice.
quite a bit to talk about today for those who are tuning in. The first thing we're going to talk about is this last event that it's the event that could have been, but kind of wasn't. And there was an interesting thread on Twitter and about why this was from the people behind Hust. Um, Basically we saw a couple two partial halos. I think one was a full halo that was supposed to hit us. And it didn't. Well, we got part of it, but it wasn't like, what we expect. And there's a reason for that. So we're gonna go into that and talk about it.
Yeah. Which, on that note, that Halo I just realized was also a 100% probability of arrival
It
with us.
was. It was. It
First
was
time I've ever seen that.
yeah, it wasn't like 99%, it was 100%. Oh, and on top of that, it came like about 20, well, it was almost a day later.
24 hours later. Yeah,
Yeah. So
something
everything
like that.
about it was just off. But we'll go into that. So we'll have you share that Twitter thread because
All right.
it was quite insightful as to why this forecasting is very difficult when we have basically a two-dimensional view and we're trying to model things in 3D.
Just so we can see the actual data too. So we had a very
And it
tiny,
looks like
small
that's
impulse
the
the
solar wind
25th.
data from it,
Mm-hmm.
right?
And it was very little, some activity. It could have been some nice periods of mostly variable BZ. Don't see any real flux ropes. There was a second impulse. I honestly can't. Must have been that one there. That little tiny dip. I'm not even sure. There was a
Yeah.
second impulse, and it was easier to see when you're zoomed in on it, but for the second full Halo CME. And it was basically nothing. So we were like, what the heck? Why? This was supposed to be an official arrival. So
Yeah. So
we're going to read this, or I'm going to read this rather, word for everybody, so that way everyone can go into it because it is far worth having. This is Professor Matthew Owens, and yes, he's part of the Huxt team and wanted to describe why it was a kind of a moment.
yeah, what is that? A CME?
Yes, we didn't use that. I forgot. CME. CMEMN. You can't spell it out. It doesn't work. Okay, so this week's space weather and forecasts have raised a lot of important issues, and I think it's worth having a bit of post-mortem to see what can be learned, which honestly, all of our forecasts should be doing that. This is going to be a long thread, which again, I'm just going to read it all, so that's fine. Part one, A Tale of Two CMEs. Oh, yeah. It was the best of CME arrival times. It was the worst of CME arrival times. It was the age of forecast wisdom. It was the age of forecast foolishness. Props if you know what book that's from. There were two CMEs, is the point. CME 1 was an apparently slow partial halo, very early Saturday. CME 2 was an apparently fast full halo late on the afternoon on Sunday.
Yep.
Part
And
2 shows.
there's the signature there.
Oh, yes. Now then we've got our Halo CME doing his little analysis on it as well, showing the imagery from LASCO differential imaging. And this is a running differential from, looks like 512 to 524.
Yeah. And it really wasn't all that bright to begin with. Well,
No.
I guess in those images below they were, but this is where it gets interesting.
So those coronagraph images are 2D projections of 3D structures. So we have to fit those images with a geometric model to work out the true speed and direction. So imagining having the whole world and flattening it to a piece of paper, that's all we have to do for everyone else at least. There is some cool structures here. I won't necessarily go over them, but it shows how circles can look spherical and da da da.
Yeah,
This is something of a dark art. Love that phrasing. And different
I do
people will get
too.
different results. But the general consensus on Monday was that A, CME1 was fairly slow, about 600 kilometers a second, narrow, and only going to clip the Earth at best. CME2 was fast, about 1050 kilometers per second, wide and heading straight at Earth, which, yes, most of us thought that. And then we've even got the Hux runtimes, or the actual runtime for it, and then the velocity and the degree info seen in LASGO. We feed those CME properties into our solar wind model, which is the Hux model in this case, to estimate when the CMEs will arrive at Earth, but there's uncertainty in those numbers, so we perturb slightly and rerun the models to see how the result changes. That's 500 times. So that means for CME number 2, it was ran 500 out of 500 times, and it hit Earth.
Yeah.
Damn.
Right.
Again, I've never seen that. I just like making that as big a point as possible. By perturbing the CME directions and speeds, we estimated that CME1 had a 63% chance. Oh, he lowered to, well, 63% chance of hitting Earth, most likely late on Tuesday, and CME1 was a 99% hit sometime
Yeah,
after.
99.
And that was just the first CME part of it.
Yeah.
So what happened in near Earth space? 2 shocks, presumably driven by the 2 CMEs, did eventually arrive. Shock number 1 was about 8 p.m. on Tuesday, within 90 minutes of the 2-day forecast. Woo! Shock number 2, 1 p.m. on Thursday, which was more than a day later.
Yes.
Drastic differences. Looking back inside the sausage factory, still don't get that one. Warning, it may put you off consuming space weather forecasts in the future. And by that, I would like to think he meant taking it seriously. So how can one CME be forecast so well and the second be a complete forecast bust? 2 broad possibilities. The model is wrong or the inputs to the model are wrong. Now, the model is wrong. All models are wrong, but some models are still useful. That's a very popular quote going around our community now.
Yes.
But forecasts were similar from the Enlil model, and it is possible that Hux and Enlil are wrong in the same way. They treat the solar wind in the same way, so makes sense. So in this case, it's the inputs. More likely, the inputs to the models are wrong, which raises 2 further possibilities. The ambient solar wind from a coronal model, the WSA part of it, has large errors, and we account for this reasonably with the ensembles, where they just perturb things slightly. Or B, the CME properties are wrong. Let's sanity check the CME properties. We know from in situ observations when the CME arrived at Earth and how fast it was moving. We know fairly well from coronagraphs when it entered the solar wind model at 0.1 AU. Let's assume we don't know the initial speed very well. The time between CME1 at 0.1 AU and the shock 1 at 1 AU was 3.65 days. That gives an average transit speed of 427 kilometers per second. Shock 1 was moving at 322 kilometers per second when it arrived at Earth. So CME1 speed estimated from the coronagraphs of 615 kilometers per second seems plausible. No issue there. CMEs, they experience a drag force as they move through the solar wind. CMEs moving faster than the ambient wind slow down, and vice versa. The slower ones are sped up by the ambient wind. Transit speed should be roughly the average of initial and final speeds, which again also makes sense.
Yeah.
There were 3.73 days between shock 2 at 1 AU and the estimated CME2 time at 0.1 AU. That's transit speed of 418 kilometers per second. It was 400 kilometers at Earth. So if it actually started at 1050 kilometers per second, it had to decelerate almost instantaneously.
Right.
Something is very wrong with that. All right, I'm bringing this view up, and this is where I think the more important part, I would say, is interpreting, or the fact that we can't interpret looking at a flat view of a 3-dimensional world, that we have a fast CME coming at us that's narrow or a slow CME coming at us that is wide. And this video really does, I would say, kind of make the point. You have an L1 view at the bottom for both, and you have an off-axis view, which doesn't exist right now. Hint, hint, everyone. And this shows the differences. The purple one being much, much, much faster, and the blue one being much, much, much slower, but they both look the same. There is no difference when you take a 2-dimensional cross-section in that to figure out which one is faster than the other. So CME2 could have been wider and slower than the original estimate and still fit the chronograph observations, so let's consider this scenario. The slower speed puts CME2 at 0.1 AU approximately 4 hours later too. So now we have a CME2 average transit speed of 438 kilometers per second, which is somewhere between the initial speed of 750 and the final speed of 400. More plausible, at least in retrospect, now that we can look at it.
Yeah.
Oh, excuse me. Thus, CME properties being wrong is the likely cost of the forecast burst, and I'd say that's likely going to be the case every single time.
Yeah.
How do we do better? In the long term, we need multiple viewpoints on CMEs, such as the Vigil mission going to L5, and we need to start routinely tracking CMEs in heliospheric imagers, preferably from L5 and L4, so we have basically a similar stereo A and B alignment when they were
Yeah.
actually doing their thing 14, 15 years ago.
Yeah, it's a shame that we lost Stereo B.
So early too.
Yeah,
Not that that would be much more useful at this point, but
right.
so short term, we need far better estimates of the uncertainty in coronagraph derived CME parameters on a case by case basis and to use ensemble systems to incorporate that uncertainty in the forecasts. He says anyone still here at the end deserves a medal, but we think that everyone should be required to read this anyway. So yeah,
So
here we are.
everybody, you all got your medal for going through that talk.
I mean, we held you hostage through it, but that's not the point. Yet the
But
point is, it needs to be done.
it needs to be done. So you could take that, and now as we talk about this new stuff, that came out in the last couple of days, keep in mind about forecasting and how we're very limited on our view.
And this is especially
So,
true when we have multiple CMEs going from the front side
yes,
and the back side to make things even worse, figuring out which way they're going. Which
yeah,
also, if we had L4 and L5 observations, wouldn't be as much of an issue.
yeah, we'd be able to differentiate those a little bit better. So anyway, we have what
I'm
was
just
it?
going to run the running imagery at
Yeah,
this
running
point.
because I think there's three Halo
So
sensors.
there's a backside
Yeah,
CME about
there's one
300
backside
or
and
so.
like two front side, I think, right? If I
Yes,
remember.
actually, you can kind of see the backside. There's like a there. So you can kind of see it in the
Yeah,
differential imagery here. So, and I'm going to assume they're all related because usually when flares go off at the same time, they're magnetically connected in some way.
yeah, it certainly
Makes sense.
seems that way. So,
So
because
we got
then,
the backside CME going, which just went. We've got clearly an eruption going on here in the southeast. And then we've got an eclipse, which is
yeah,
terrible, terrible timing.
a terrible time for that.
Apparently, GOES imagery is better, and I never think to load GOES imagery. So, sorry,
Yeah,
guys. As we get closer into, actually, did I skip the front one?
yeah, where'd it go? I thought I saw it.
Oh, I did skip it. Whoops. It was
Like
like
I thought I saw
600.
the little poofy. Boop. It was really well placed. It's a good location.
I think my running difference time is not in a good spot. It's not getting much contrast. So let's go ahead and do this. I will just take the running difference off for now so we can actually see it.
Because yeah, it shows pretty good in 211 here. You can see the
So there was the side one. There's the one here.
oh,
There's
there's
an
the
eclipse.
and now we're back.
That takes up like an hour and a half of time too.
It's such a bummer. It really is.
Not the best. But
Yeah.
those are the ones we're looking at least right now. And
Yep.
then there is one later as well.
Mm-hmm.
That looks like something.
It kind of goes
And then
across the whole front.
yeah, and then the western side here,
Yeah.
which there's not quite enough imagery to finish that one yet. That was in progress as we were speaking.
Mm-hmm.
So
It's
let's
got the
jump to
mess.
let's
The
go.
mess.
CMS.
Yeah, see a
God,
mess,
how
see a
or
mess.
wait, CMS? We'll figure
I
that one
think it's
out.
just see a mess. I definitely have a lot of respect for the people that are doing the forecasting on this right now because it's yeah, it's a mess.
Actually, there's a good way to reproduce the feelings for everybody watching. So if you really want to know what's going on, the way to do it is to bang your head against the wall a couple times, wait a few minutes, and then do it again. Then try to do some advanced math problems.
And then do it again.
As far as the CMEs, so I'm going to zoom in a little bit. This is the backside. This has no bearing on Earth whatsoever. This
Mhm.
is where things get tricky. The north, or yeah, northwest one,
Yeah, you can start to see it emerge
hard to
there.
see it there. It does come out a little more here. Now it's kind of a fainter, but it's a fairly thin partial halo, at least from
Yep.
what you can see. And then there is the full halo, or what I'll call full halo at least.
Oh
It's not
God,
quite
what
full
what a mess.
right here. Now, I'll say in Glasgow, at least the view, there have been nothing else launching since then. There looks like a backside one from the
Yeah.
top. But and then there's not enough imagery yet for the eruptions currently taking place. So
Yeah.
that's another possibility. But the idea is that
So yeah, thing
one, two,
one, thing two,
three,
thing three.
1, 2, 3, 1, 2, 3. It's like a dance.
Yeah. So basically we have two. what kind of asymmetrical halos, I would say.
Yeah, one was, if we want to go ahead, I'll just throw
Yeah,
Hext up here too. I like their visual one because it really
yeah, I
makes,
liked it too. Because this is it's like a top-down view, and you can see basically it's coming from like all directions. I mean, the
yeah, look
sun,
at all these CMEs to start off, like, woof.
so
But
many.
it is the purple and pink one we're looking at here.
Yep.
The pink one, the purple one being the first one we saw that was kind of narrow, then there's the pink wider one, which is looking to overtake that one.
Yeah.
Let's see, we've got an arrival time. Well, I'm not going to try to figure that out in video. That would be silly.
Yeah, I think it's the 30th. It's
Oh,
like
this is new.
so they ran it again.
Ensemble using 27.
That's 27.
Yeah, 1200.
Okay.
Well, that's different. The probabilities here are much higher.
Yeah, so
This one gives a 100% probability at CME 11, which was the last eruption we saw
yep.
near full halo, and then a 78% for 9. They are going to overtake each other, it looks like, though. The arrival times are the same. I mean, there's an hour difference in the runtime here, but that's for our purposes pretty much the same.
Yeah, so that's gonna be and it's like early on the 30th.
July 30th, about 0100 UT, which
Yeah.
for us at least, so 1 a.m.
Yep.
on the
Yeah,
30th.
that's kind of what it looks like. And this is I just gotta, remind like because well, I'm not in the Great Lakes region right now, but from the Great Lakes region, yeah, so it would be our local time.
Yeah, if you want to have confusion there, because so that was 1 a.m. Wait, we're
Eastern,
2
right?
a.m. now. So it's
Yeah.
-4 UTC at this point because of the
Okay.
stupid hour forward. But
Yeah,
so 2 a.m. Eastern on the 30th, which is Tuesday morning.
yes.
So
Yep.
the night of Monday night or going as late as Tuesday night into Wednesday morning if you want to do like an error range.
Yeah. And then of course, this could well, like we learned from the last one, this could end up
A dud.
a dud or showing up late or showing up, we'll see. They seem pretty, I mean, I'm sure something's gonna come of this. I just
Something's
don't
gonna
know.
happen. We'll get something. But
Something's
the
gonna
rest of it,
happen.
we'll see what happens at L1.
Yeah, so what happens at L1? Yeah. I think Swipsy put out a G2 for this, I
Yeah, they
believe.
finally upped it again, and then
Yeah.
Met put out a G3, if I'm not mistaken, as well.
Yep. Yeah, so I mean in theory, it could lead to something pretty decent, but yeah, we're just gonna have to see given the enlightenment on this last event.
Hopefully, we'll be a little more aware. Well, not us, because we, of course, already were, but everybody else being a little less hopeful. Is that the word I want to use?
Yeah, I don't want, so like the media, I guarantee is gonna latch onto this and it's gonna be one of the, the hype fest that we always talk about.
Yep.
Just keep that in mind. Like we like to be optimistic about stuff too, but you have to be realistic with these types of things because we're just limited. We just like we need more things to looking at structures and we just don't have that yet. So
Shoot,
it's
what was Tanya's quote for this that I was going to use?
well,
I already forgot it.
she used the model one, which was funny.
Let's
Oh yeah, what was it? The Media Hype Fest one. Find it in the chat.
mm-hmm. Yeah.
But anyway, so yeah, we have this to look for. And then to be honest, like to just keep a lookout this whole week because I guarantee as soon as we get off of here,
More
we're gonna
stuff.
get another flare. And then we also have a possible decent flare player coming into
Oh, that's true.
view within the next couple days. Because it's been really active on the far side of the sun. Now, a lot of things can happen in that time frame, so we just gotta wait till we get eyes on it, but that could be something to look forward to in the next week. So it should be a pretty active week in space weather. It'll keep us busy.
Oh, it's a little farther on the far side than I thought. So
Okay, so
maybe another
maybe
3 or 4 days, I would say.
okay, so
2
yeah,
was a little optimistic.
okay, no worries. But yeah, so we have that to look forward to. But right now we have a couple of them that are just flaring away, and they seem to be producing CME. So
And we're at least center disk. So
that's under
likely aurora activity should be at least elevated.
yeah, yeah.
That's all I'm willing to say.
Yeah, elevated. I don't want to put any numbers on this.
No numbers, no feelings, no structure, nothing. Just maybe something at some time.
Something is on the way. So
This is the most confident broadcast we've ever had.
I know it's like it gets worse and worse as we start getting these events that like fall apart and we start realizing where all the weak points are, or as they say in the advertising world, where the pain points are.
They are painful. And we
Gotta
seem to have more
recognize
of those than non-ones, though.
gotta recognize your pain points and rectify those. But unfortunately for us, to rectify our pain point of not having a satellite looking at this stuff, that those are big ticket items. But we have one mission going up. What is it, Virgil, I think? But that's like 2030, so we're like 5 years
It'll be
away.
a while. I mean, we're talking L4, L5.
Yeah,
That's a little over 1 AU out, and I'm assuming there's gonna have to do some flybys around other planets to get there. Yeah, it's gonna be
yeah,
months and months.
it's gonna be a while. So anyway, so we'll come back. Well, now we'll switch gears. So anyway, that's the forecast. We have something on the way, but now I'll switch gears into the other problems that we have because
Yay.
it's summertime and we have things to deal with. So I'll share my desktop here. And we are going to go to what I have up. So as you can see, by the very first map, it's summertime. It's hot and dry. The Pacific Northwest in California is on fire, extending up into Canada as well.
That is not an
So
exaggeration.
no,
Wow.
there's a lot going on. And this is going to be our big battle. When you thought battling the weather was enough, now we have this. So a lot of smoke to contend with. It does kind of tend to come and go in waves, like depending on where you're at. You can you'll get like patches of dense smoke, but then it kind of clears out, but then you get another patch coming in, and that's just how it is. There's a couple different things you could look at for smoke. Fire.airnow.gov is one of them. Where kind of this gives you the air quality and then it overlays it with some of the smoke maps. And you can click on the different fires. There's two really big ones right now, one in Northern California and one in Oregon. And those are kind of the biggest culprits for the most of the smoke. But as you can see, there's just a ton of these little fires.
Ugh.
It's unfortunate because like they got rain, but what the rain comes with the lightning a lot of times, and the lightning starts more fires. So you're like in this feedback loop and it's not a good one. Another map for it is I like to use Astropheric.
My favorite.
Yeah, this one kind of gives you a visualization. Here, let's do.
And a forecast.
Yeah, and a forecast. Now, of course, the smoke forecast is experimental, so you have to take it with a grain of salt. Fires are very dynamic situations, and they can change drastically in an hour. But it kind of gives you a feel for different weather patterns and how the smoke's going to move around. The thing is, it takes a little bit for it to load in Astropheric, but you can kind of scroll through it and see how it's going to move. Pacific Northwest has a lot of problems. It moves into the Midwest, but there are patches of decent, like especially the Eastern UP seems to get a little bit of break from it, which is nice. So smoke map, you have to keep that in the back of your mind, and then you also keep the weather in the back of mind. Pivotal Weather also does have
Oh, cool.
vertically integrated smoke maps as well. This is a little different because you see Astropheric kind of shows like it seems like it's worse than it is, but then it might be. This kind of is more like the forget exactly what exactly this measurement is, but it's like the parts per
5
million measurement.
kilograms per mass or per meter squared.
Uh,
So that's how much smoke,
per
massive smoke, basically
okay.
per area squared.
Yeah, because the ones that I've seen, it goes by the parts per million, like the particulate matter that's up there. So
Yeah.
this one is a little bit different than
So
that.
this is 10 to the minus 5, so it's in tens of parts per million.
So that's another way of looking at it. And it has like the forecast hours, so you can click through and it'll change on the map and you kind of see where the fires are. So that's another one. In Pivotal Weather as well as the models that, so you can look at your
Oh,
HRRR,
cool.
things
I
like
didn't know
that.
anything about the site.
Yeah, Pivotal Weather is great. It's more of a desktop site because it's not an app, but this is where I like to go to get the
Oh, that's where those come from. Okay.
yeah, because this is updated every hour. So with the apps, they're not updated hourly. You have to pay for that. You pay for the convenience of an app, or you can just go to this website and pull it up yourself. for free.
Do work for free, pay for
Yeah.
convenience. Yeah.
But the thing about HRRR is it doesn't go out that far, so you have to. This is more like day of type stuff. I think I covered it last time. So I think weather-wise, it wasn't actually looking too terrible. In parts there is a system coming through. And I think when I last looked at it, let's see if we can do. Where's my clouds on here? My little faces are.
I know at least for Ohio on Monday to tomorrow and Sunday. Wait, today's Saturday. So today and tomorrow it's clear through here at
Yeah,
least.
so let's go like Monday at 1 a.m. or Tuesday at yeah, so there is a system coming through. And I've seen this map updated different ways depending on which model you're looking at. Where some parts were clearer than others, so it's gonna change. Just keep an eye on it, but it might be a battle between the clouds and smoke, like I said last time, unfortunately.
And still lack of night for summer. Just all
Yeah,
around bad conditions.
yeah, it's this will be nice in the fall when things calm down, the fires go away and we get clearer nights, clearer, less hazy nights. So
At least hopefully.
yeah, hopefully.
Getting worried our winters are going to turn more into summers again.
Yeah, we don't get much of winter anymore in the Chicago area as
Nope.
well. It's just warm.
Snow is rare.
Yeah. So anyway, that's our the long and short of it, I guess.
And I had to talk pretty fast for some of that too, 'cause that was a lot to cover. Whew,
Yeah, look, I think we still did it under like right at a half hour, which is
28 minutes.
but I mean
Half an hour being the goal.
we don't go in it too terribly hard. It kind of just give you the overviews because it's tough because this stuff is gonna change between now and tomorrow. When we get more because they got to model that new one. So
And
I guess
we gotta wait for Lasgo imagery for that one. So like, yeah, there's lots of stuff going on now.
yeah,
Again,
I guess the point is be on alert this week. If you're in a northern tiered location, it wouldn't behoove you to go out and check it out, you know.
Monday night onwards.
Yeah. So that's our little stint of the day. So thanks again for tuning in. And if we get anything major, we'll do like an emergency. Let's talk about this. But I mean, I don't know if we'll have to because we're basically saying, hey, this is gonna it looks like it's gonna keep flaring a little bit.
We get maybe what something high end magnetic field wise that could be potentially
Yeah.
epic.
Yeah,
Not
then we can,
necessarily something May 11th ish, but
yeah, but then we can convene and have a nice little group chitty chat.
the council of groups
Yeah,
or
the
of
Council of Groups, the Space
we need
Weather.
a name. We need a name for us four.
We do. That'll be our
Figure that out
project.
later.
All right. Well, on that note, I will end this live stream and we will catch you next time.
Yep.